Okay, we will go over the tide problem. So I wanted to see if there were any from the book problems that we want to talk about. Any suggestions? '79's been offered. What's that?
74.
Okay, we got 74 and 79.
And 99.
99.
80.
So we got 74, 79, 98, and 99. I'm going to do the tide. I'm going to do the tide, yeah. Yeah. Other requests? Okay, don't pass it in. You can look at it while I'm doing this. Thank you for knowing the system, but you can look at it. All right. So this one, 74. So what I told you was first we got to get it into the form that we can interpret, which means get a 1/2 out. So it'll be 1/2 times theta minus what? So theta minus what value would result in minus pi. So what do we need there in the blank spot so that it equals 1/2 theta minus pi? Someone said 2 pi. So if you're not... So let's just give it a shot. So it's like, all right, we'll just try it and see if it works. So if we multiply that out, what do we get? 1/2 theta minus 1/2 times 2 pi, which is 1/2 times 2 pi minus pi. So it works. You see? So this is the form that we need so that we can manage the shift correctly. So we want to have that shift be in parentheses. Okay, so then that's not going to move down. Let's see here. Let's just try it. So first thing, so we want to sketch this without a calculator. First thing. So I'm going to, what I'll do is, we'll just write that down here. So 2/3 cosine of 1/2 x minus 2 pi minus 5. Is that what we said? All right, cool. So what do we do first? Midline. Where's the midline? Midline's at -5. So let's graph that. What will the max be? Or how would we get that? So our midline's here at -5. What is the amplitude? The amplitude is 2/3. And so if we're at -5, to get to the max from there, we'll go up 2/3 and the min down 2/3. So we'll go up 2/3, whatever that is, and we'll go down 2/3. Does it show up? Yeah, okay, so here we are. Here's our midline down at -5, here's 0. And then we're going to go up 2/3 and down 2/3. Perfect. Okay, next thing we want to find. So we've got everything we need about the vertical for now. So next thing we got to start reasoning about is horizontal, which is what we need first. What will we need first? Period, right? So we're going to kind of, we just ignore, when we do the period, we ignore the shift, right? The shift doesn't affect the period. So we're really interested in this quantity, 1/2 x. So here's an important question. What interval of the quantity 1/2 x will result in one cycle of output? What interval of the quantity 1/2 x will result in one cycle? She said 2 pi. Agree with that? So that's our argument. That's what's going into cosine. That thing that's going into cosine needs to go through what interval so that we make one full cycle? 2 pi. So we've asked that question many, many, many times. We keep repeating that. Does it make sense? Don't miss it on the test tomorrow. It's like the lowest success rate question on the whole test. So get it right, okay? That's my warning to you. I want you all to get it right, but less than 10% success, okay? All right, just warning you, okay? We'll see. Maybe that will get your attention. So we want to set that equal to 2 pi, so that. And when we set it equal to 2 pi, we're talking about now a very specific value of input. Which value of input is it? What's it called? The period, right? So when the input, which is a changing quantity, when it hits the period, we want that argument to hit 2 pi.
So the B is speed, but that X is period?
No, X is a changing quantity, right? X is all values of X. But we're looking for a specific one when the cycle starts over. Right?
What is the difference between that and
B
B?
is yeah, it's like an angular speed. If this is angle, if this is time, it's like radians per second. This is like radians per second. Sure. Okay, so this is a specific X value when the cycle repeats. So what is it? 4 pi. So what is 4 pi? 12 point what? Let's see here. Agreed. 12, around 12 and a half. So here it is. Let me do x equals that. Okay, so there's our period. Okay, how do we make sense or construct the wave knowing that that's the period? What do we do? Divide by 4. So what is that divided by 4? Pi. Okay, so every quarter period is going to be pi. So we'll do a pi. Number of 1, 2, 3. Okay, so there's our quarters. I'm putting these vertical lines because we're so far away from the scale, right? So we're so far away that if I try to eyeball it, I'm going to be off. So I put these vertical lines in. Okay, and so what kind of graph do we have? So let's do it without the shift first, right? So I always recommend sketch it without that shift, with everything else right, with your midline right, and your max and your min, and your period correct, and just do plain old cosine, and then we'll do the shift later. So cosine at 0, does it start at min, midline, or max? Max. And from there it goes to midline, then min. Okay, so I'm not going to sketch it, but you can imagine the wave there. Okay, now we've got our shift. So our cosine function, that's x minus 2 pi, is that trailing behind or is that ahead? If we're subtracting from our input, if we're subtracting from the input, then our angle is how compared to just the angle x? Behind or ahead? Behind. Okay, it's behind. So the cosine is going to start first, and then later, our graph is going to start. So where's our graph going to start? 2 pi, which is here. So here's just cosine without the shift, and then 2 pi later, or 2 pi after, we're going to start. So it's going to look like this. And we can, so this will also go in the other way, so we can just from there we can do it. So I think this is the graph. Ask me.
It starts at the 6.28 area.
2 pi, right? So the shift is, so without the shift, without the vertical, without the horizontal shift, we have normal cosine, right? And so there's that one cycle, okay? So by saying minus 2 pi, the idea of that is that our angle is behind by 2 pi, which is actually half of the period, or to here. So this one starts, and it's doing its thing, and then when we get to halfway or 2 pi through the period, then ours starts, the one that we're...
That doesn't mean that you can't do the graph like on the other side.
That's right. It goes from negative infinity to infinity. It's just a way of getting the sketch started. That's right. Yeah?
So for whenever it's in the argument, the variable minus, it's always behind.
Right. So the argument, that angle is behind if it didn't have the shift. And so behind means, so which one starts first, black or blue? Here's black starting. Here we reach 2 pi, and now blue is starting, right? So it's behind. Do you see that? So that's why how it matches up with subtracting means shifting right.
You had it where it's like cosine of x minus pi. Would that just look like a sine?
Right. So if we just started it here instead, then it would be just like sine. That's right. Yep.
Is that wrong? Would you be wrong if you wrote it like that?
Yeah, because that's a different graph, right? So x minus pi would be a different graph. You'd have a different graph.
No, but I mean like, in that situation where that graph looks like sine and it's a cosine function, is it wrong to write it as a sine function?
No, it depends what they're asking for. Here they gave us this and we're coming up with the graph. But it depends what this context is. But knowing that you get the same graph, whether it's x minus pi or sine of x, that's important that you can. But yeah, go ahead.
Can you explain what happened if the leading term 2/3 in this case was negative?
Okay. Let's just see if ours is right, and then I'll do that. So the blue one we draw is what we think it is, right? Okay, so we nailed it. Questions on graphing before I answer his question? Question on graphing this one. Got all the parts and pieces, lots going on here. Okay, so he asked about what if, now if we took this whole term here, the cosine term, and made it negative. So what will that do? Yeah, so if you imagine the -5 not being there, we would be here at the midline here, right? And what we're doing is taking the opposite of all the y values. So what's it going to do? It's going to do this. So yeah, it's like a flip over the midline, but then we're going to move the whole thing down 5. You see? Okay, so it should be the black one. Now. So it's flipped vertically over the midline if you take the negative.
Is that just changing to an arcsine?
What's that?
Is that just changing like, was that like arc cosine?
No.
Negative?
No. No. The arc cosine is the inverse function. It's reversing the input and output. Totally different. It's totally different. This is still a standard sine function, sinusoidal function. Okay, questions on this example? Okay, I think the next one was 79. Okay, so we have time for maybe 2 of these. So A, B, C, or D? Any nominations? So there was a couple for C, 1 for B, and 1 for D. Let's do B and C. Okay, so for B, first thing, what do we want to look at first? Midline. So given a graph, how do we determine the midline? Yeah, so look at the max, which is 2, minimum is -4, and so? Yeah, so somehow you got to figure out what's the halfway point between those 2 y values. So you could average them, or you could do some guess and check, or whatever. Okay, so the midline then would be -1. Next, amplitude. Distance from the maximum to where? To the midline, which is 3. Okay, we're rolling. We're doing good. All right, next, period. So we're going to estimate. Okay, we're going to estimate the period. So everyone might have a slightly different answer for this. So there's different ways to do this. You can estimate the x value there, and then 1 full cycle would be to here. So estimate that interval width. We can do max to max. So from there to there is the period, min to min, etc. So let's take a look here. It looks like here's the minimum is pretty close to 3.5. And then this looks pretty close to 6.7. So based on my estimates there of 3.5 to 6.7, what's the period? 3.2. Okay, so what are reasonable estimates? 3.1. Someone said pi. Yeah, so it looks like it could be around pi. Maybe that's what they were kind of going after here was pi, but we can't know that for sure. 3.2. These are all reasonable estimates of what the period would be. We'll use 3.2. I went minimum to minimum. Is it okay? All right, so then from the period we get that value, we want that coefficient b. So b times the input. So when the input reaches the period of 3.2, then we want the argument to reach what? The argument should reach 2 pi to get 1 full cycle of values. So we're solving for this, we're trying to write the equation, so we need that b value. And when the input hits the period, that argument should hit 2 pi, and that will give us what b should be. So b is 2 pi over 3.2. Okay, so let's write it as a sine function, and we'll do the shift last, just like when we sketch them. We'll do the shift last. So as a sine function, I'll write it up here. So what comes before the sine? Amplitude, which is 3. What do we add out here? That's our midline, so we shift the whole thing down. Our amplitude is sine, and then we got that 2 pi over 3.2. We're going to do both. Yeah, we can do both. That's the whole thing, that cosine and sine are just a shift away from each other. So we're going to write it 2 different ways. Both. Yeah. So if it doesn't specify, basically you have your choice. Is the idea. But if it might tell you use cosine or use sine. All right. So all that's left is what shift do we need? So we got to just get the shift right. So what we do is we look at find what we starting at 0, what we normally think of as the sine. The sine normally at 0 starts where? The max, the midline, or the min? Sine. Midline at 0, right? So and then goes to, so it starts at 0 and then goes up to the max, right? Midline, min. So that's our, starting at 0, that's our sine curve, right? So look for that pattern somewhere close to the y-axis. From the midline, yep, from the midline, right? So here's our what we normally think of as sine starting at 0, right there, right? Okay, so here's actual sine then. Actual sine is like this. So our graph, behind or ahead? Behind. So subtract or add? Subtract. How much? Yeah, 1.2. So it's behind, it starts behind 1.2.
Did you also say that this is where the midline hits the graph first, starting at 0? So if you start at 0 and you see where the midline hits the graph, that's also where.
Yeah, but if it hit and was going down at that point, we need a different place that it hits. We want the place where it hits and goes up, because that's our normal, right? Sine goes up. So you can't just say it's the first place the midline hits, because if it's going down there.
And then it's like cosine, that might not work because it's going down or something like that.
Well, for instance, if your y-axis, say the y-axis was right here, you wouldn't want to shift sine to there because now it's going down. You see, it's going down. So it's the either left or right where it hits the midline, but then it's heading up. Okay, so that's the sine. Any questions about the sine version of this function? Okay, so now if we want to do cosine, let's see. Does the black show up on the blue? Can you see that? Kinda. Sure. Okay. I'll do it over here. See. So 3 cosine. Everything else is the same except the shift. Same period, same amplitude, same midline. So now we want to get the right shift for cosine. Again, so we think of just the plain cosine function starting at 0. What does that look like? Does it start at the max, the midline, or the min? Max, and goes to? Yeah, it's this thing, right? It's this thing. So we look around 0 and we look for that pattern. So I see it. Let me do it in blue. So how about right here? See it right there? So that's our, well, here's that cosine shape. And cosine would actually, if there was no shift, cosine would actually do this. So ours, is it ahead or behind that one? Ahead. So we're going to add or subtract? Add. How much do we add? Again, it looks like 1.2, right? So we're going to add 1.2. Don't add negative 1.2 because that's like subtracting 1.2. We want to make sure we're adding 1.2. That says x plus 1.2. So those two should give us the same graph, should give us the black graph that we were given in the first place. Any questions? Yeah?
In general, if you had to do this on like a different equation, but similar inputs and things, would the magnitude for sine and cosine, the shift be the same?
Yeah, no, so there's always exceptions. So it happened that when we did sine, we subtracted 1.2, and cosine we added. Won't always be the case. Yeah, it depends on how the period's working into that too, and how much the shift is. So don't you get into trouble if you kind of look for things to memorize like that. So be careful. Just reason out each one. Other questions? Okay, did we say we do C too? So here's C. Okay, midline. Let's go fast. Getting good at this. Midline is 1. Amplitude is 1. Okay, period. Period looks like it sure looks like 12.5. And that might be some multiple of pi. Their intention might be that some multiple of pi, but without a pi scale, we don't know that for sure. So this is as good as, what is that? Is that about 4 pi? Yeah, so it's probably that the period is 4 pi, and that they didn't put a pi scale. So that 12.5 is just as good of an estimate as 4 pi. So this we can't know for sure. You know me better than that. I'm not. No, it's not. It's not about trying to trick you on estimating things. That's not. So I'm trying to find out if you get it. Okay, so we'll just use 12.5, and so then our period. So again, our argument. When the input reaches the period, the argument needs to reach 2 pi. So, the value of b is 2 pi over 12.5. Okay, so
if we wrote it as 4 pi, when you took it to the other side, would that
b equals b times, so if it's 4 pi, so what would b be? 2 pi over 4 pi, which is? Just 1/2. 1/2. So using 4 pi as the period, you'd have b as 1/2. And this should be pretty close to 1/2. If you actually got that decimal approximation, this should be pretty close. So yeah, either way. So either are valid. Okay. Cool. So we can get it going. So what does this one look like? Or is there one of the two we can do without a shift? Clearly, this is cosine without a shift. So let's just do that first. So cosine of 2 pi over 12.5 is our b value times x plus 1 amplitude 1. So I think that's it. That's a cosine. It's just moved up 1, and then the period's adjusted so that it's about 12.5. Questions on the cosine version? Okay, sine version. So to get the sine version, See red? So we need a shift, okay? We need a shift. So what do? We look for, given just sine starting at 0, we look for that shape, right? We look for that shape starting midline, max, midline, min. So how can we do it there? No, that goes down. See, that goes down. So we don't want to make that. So we want to come up to right about there. So this would be one way to do it. We could base it on this right here. So actual sine does this. Ours does this. Ours is then ahead or behind? It's behind. How much behind? 9.5. So minus 9.5.
If you could see the graph that way, if you could see the graph that way, then you could start it by whatever.
Ahead by a quarter period. Yep, exactly. So you could look at this one too. This is also right there like that. So it's ahead by 1/4 of the period.
Wait, so where did you stop? You started at 10.
Here?
Yeah, you started at 10, right?
Yeah? It doesn't really matter. So as long as we know we're starting the right place, what we need is that shift. That's what we're going after. That's our shift. So where it stops doesn't matter. So what we want is we want to take
I thought that was your starting point.
here. Yeah, that's what it is. But okay, so you got it? Okay, cool. Yeah, so this is sine without the shift, and this is our starting. So I'm saying that it starts behind 9.5. So we're going to subtract 9.5. And then he also noticed that's 3/4 of the period. He also noticed that we could start 1/4 of the period ahead. So plus 1/4 of the period. Yeah, it would also work. Questions on 79? Okay. So we have time for one of these two if we want to get to the tide problem. So either 98 or 99. 98's the buoy, 99 is the big Ferris wheel. All in favor of 98? All in favor of 99? It's a tie. Let's vote again. All in favor of 98? All in favor of 99? 98's have it. Okay, so it moves vertically 4.2 feet between its high and low points every 9 seconds. So it's at its high point first and then drops to its lowest point, sea level, before returning back to its highest point, completing a full cycle in 9 seconds. So, based on the information given, we have to determine, let's start with max, min, and midline. And then, so max, min, and midline. So according to the information, what is the min, what's the midline, and what's the max? So here's the key things here. It says, its lowest point to its lowest point, sea level. Okay? So what's the minimum? I think that's implying that the minimum is 0. So our minimum is 0. And so then if it moves vertically 4.2 feet between its high and low point, then what's our max? I read that as 4.2 also. it's a total distance of 4.2 between its min and max. Okay, so what's the midline? 2.1. And what's the amplitude? Also 2.1. Make sense so far? Okay, we have a good start here. So we got the midline at 2.1, so it's going to go up and down between 0, sea level, and a max of 4.2. And it says when we look out the window, it was at its highest point. And then in 9 seconds, it was back to its highest point. Is that right? Full cycle in 9 seconds. So it's going to be at this highest point at 0, and it's going to be its highest point at 9 seconds. Okay? What do we do then to break it down here? Divide by 4. So that's going to be, I think, 2.25. So then its high point is going to go to the midline at 2.25, minimum at 4.5. 6.75, and back to the max. Are we good? Vertical position measured in feet. All right, so we need a function for that. What would you do? So sine or cosine? Making it as easy as we can on ourselves. Cosine, all right? So cosine of what? So we got to fill in the gaps now. Midline is 2.1. Amplitude is 2.1. And so we're left with b times x, right? B times t. So when we hit 9 seconds, we want b times t to be 2 pi. So when the input hits 9, we want the argument to reach 2 pi. So we get a full cycle. So I think it's 2 pi over 9. What do we think? We got it? Let's see. That's it.
And you know there's no shift on this because it's doing exactly what a cosine.
Exactly. So yeah, so at 0, it's at the max, and then it's going midline min, midline max, and that's exactly what cosine does without a shift.
Right. And if it was a shift, like just, it wouldn't start at 0 at the max, it would start somewhere else.
Yeah, if you're going to use cosine and it starts at the midline or at the min, then you need a shift. Yep, you need a shift. So now they're asking you questions about to talk about the different quantities and how they change and how they change together. So I'll leave that to you. Okay, I'll leave that to you. Okay, so similar to this was the tide problem. So this is the buoy going up and down, and the tide goes in and out. Let's do that one. Okay, so here's the tide. Turn those off. Oh, and just those later. Okay, so it says at high tide the shoreline is 20 yards from the stake. So here's the stake. High tide is when the water comes in the furthest, right? So that's 20 yards from the edge of the water to the stake. Is that the min or the max? So here's high tide is coming in, and we're measuring the distance between the shore and the stake.
At high tide, it's
So at high, he's saying at high tide it's the min, because that distance is the least. That's right. So at high tide, we have the min, and that's just what I warned you about Wednesday or Monday. So at high tide, we have the min, and it's a value of 20. At low tide is when the water has receded the most, and so that distance is 58, and that's the greatest the distance is, 58. So from that we need to get the midline and the amplitude. How do we get the midline? With the min and the max, midline, split the difference, right? So however you can figure out what's halfway between those two. So you could take those two and average them. You could take that distance and divide it by 2. There's different ways to do it. But so yeah, so the distance between those is 38, and then half of that would be 19. That would be our amplitude. So take that full distance, which is 58 minus 20, divide by 2, gives you 19. And so the midline would be up 19 from 20, or halfway between these two. 39. What happened? 58 is the max. 58. Okay, so there we go. Got our midline at 39, our min at 20, our max at 58. Cool. All right. Next. Now we need to start talking about what's happening this way. What's that? Period. Okay, how are we going to get that?
It takes 12 hours, right?
It says high tide is at midnight and then noon. So that would be, is that measuring max to max or min to min? If high tide is at midnight and noon. It's min to min, right? And so that min to min is 12 hours. So if we're writing the equation, we need B. So we're saying B times when our input hits 12 hours, we want the argument to hit 2 pi. So B is pi over 6. Okay, let's see. So do we have everything we need? So let's just map out some points. So it says at midnight, are we at high tide or low tide? High tide? So here, at midnight. Nope. High tide is when the water is the closest in to the stake, so it's our minimum. That's what we said. And then we'll be back at high tide at midnight. So then when we're at low tide, halfway, 6. And then at the fourth point, which would be every 3 hours, we're going to hit midline. So we want to do sine or cosine first? Cosine. Is it cosine without a shift? What's that? Yeah, so isn't it this situation we saw earlier, right? It's cosine, but flip this way. So we can avoid the shift by doing negative cosine. See that? So we can avoid the shift by doing cosine flipped over the midline. So we negative amplitude. 19. Cosine. What's the argument? 5 or 6 t. I need x for my software. All right. Plus 39. That should do it. We've done everything correctly.
Why would it be negative?
Because notice what we're doing here. So we're mapping out like that. And what does the cosine do? Starts with max, right? So it's this flip we saw earlier in class using negative. It flips it over the midline. I think I said write it both ways, right? So we just need, everything's the same except the shift now. Everything's the same except the shift. So why?
So when you put negative up there, that means there is no shift. You just are just telling people that's
So we're telling it not to shift it and take the cosine and take all the opposite values, opposite output values. And so if we were without a vertical shift, opposite would just be flipping over 0, right? Flipping over the midline. And then we move it up. So it flips it over the midline. Okay, so as a sine, okay, so there's sine without a shift. Okay, so I just graph sine with everything else equal, everything else the same without a shift. So what do we need to do to the sine to get it to be the same as what we know is the true graph, the blue one? Do we want to make it fall behind, or do we want to make it be ahead of the purple one? We want to shift it right. Yeah, so we want to subtract to get it falling behind this one, right? We want to subtract to get it to fall behind the purple one so it lands on the blue one. How much are we going to subtract? I'm hearing 3. Got it. So let's say that again. So this is the true sine, and we want this one, the blue one. So we want our graph to be behind where it is now 3 hours. Right now it's 3 hours ahead of where it needs to be. So we want it to be 3 hours later. 3 hours later. So that's subtracting 3. Okay, so several announcements. Just a reminder that I'm teaching Calc 1 in the fall. And so if you're interested in being in that class, you need Calc. I need to allow, and it's reserved, so I need to allow you to get in that course. So talk to me if you're interested, if you haven't already. So tomorrow's your exam, of course. So study. What else? Friday and Monday we'll be doing new material that's on the final exam. Okay? Friday and Monday we'll do new material that's on the exam. So you can keep your homework to study. We'll turn it in Friday.
You teach now,
I do, but probably not anytime soon.
okay.
Yeah. What other? There's another announcement. I know there's another one. Yeah. Okay. Web work for extra credit is due tonight at midnight, but it'll be available always to study. Okay.
When are we going to see how we have post-test?
When I compile the grades, whenever that is. Yes, sir.
That's what you were just saying.
The post test?
No. You're gonna compile the grades like sometime before the final, so we can see how we're doing.
I'll try. I will try to do that.
Okay.
Do my best to do that. You can remind me and bug me.
All right. Okay.
Yeah, I emailed you that I was collecting it Friday. Did you notice that?
Yeah, I just
Yeah.
okay.
Okay.
Fine.
Sorry.
So, is there any no quiz and homeworks?
What's that? The last homework I'll collect Friday. So can you come again Friday to get it?
Okay.
Yeah, that'll be the last one you bring.
Okay.
Yeah. Okay. Who's first? How can I help you?
On Blackboard, it was saying that the post